Hello friends, good evening. Is it clear everything? Hello friends, good evening. Is it clear? Hello friends, good evening. Hello friends, good evening. Is it clear everything? Audio video clear? I am Saritha, UGC NET qualified. I did MTech and I did MCA. Okay friends, I am UGC NET qualified in November 2020. Thank you for watching my lessons. If you are liking my teaching and my lessons, please share with your friends, those who are preparing for the UGC NET. I am trying to cover paper 1 also. Okay, till now I covered most important topics from the operating systems and DBMS and some DI basics also I have uploaded. If you are not watched, please watch and please inform your friends also. Okay, today we are starting the software engineering. Today we will see the basics of software engineering, and we will see SDLC, different types of SDLC models, and we will see some previous year's questions also. Okay, I am here to help those who are preparing. Okay, it is free of cost also. Okay, all of you know. Please watch and please uh, inform to your friends also. Okay, that is my request, friends. Thank you for watching. If you have any doubt, if you are facing any doubt also, you can ask me. Okay friends, thank you. Now we will start our topic. Okay, this is the time, and this is it is a software in early stage. It will work fine, right? Work fine, there is no problem. And whenever the time is going, time is increasing, uh, its efficiency maybe, sorry, this is hardware. Generally hardware will work very nice at the initial state, right? After some time it will its efficiency goes some down, and after some time it will work fine. Some days it is it will work fine. After some days it will wear out. We have to throw out that software, right? That is, one is early life, and now next, constant failure rate. Constantly some problems will come. Some After some time that hardware will wear out, right? But software reliability growth, this is the software reliability growth. Initially it is like this, and it will grow like this. Okay, like hardware, it will not wear out. Slowly its reliability will increase over time. Okay, a partial list of the distinct characteristics of software compared to hardware. When we compare software and hardware, these are the different things we have to consider. Failure cause, software defects are mainly design defects. It is there is no hardware, there is nothing to wear out, but some design defects may be there in the software. Wear out. If we talk about wear out, software does not have energy related wear out phase. It is not having any engines like that, right? Software means that will be errors can occur without warning. In software we will get errors, but there is no energy related wear out. Next, repairable system concept. Periodic restarts can help fix software problems. Suppose if some problem is coming, we can if we restart that process, it can work fine. Time dependency and life cycle. Software reliability is not a function of operational time. Okay. Environmental factors do not affect software reliability. Environment factors cannot affect software reliability, right? Except it might affect program inputs. Reliability prediction. Software reliability cannot be predicted from any physical basis since it depends completely on human factors in design. Okay, any physical thing we cannot predict anything, but it is based on design only. Redundancy cannot improve software reliability if identical software components are used. If same type of components are used, it may we cannot improve software reliability. Next, interfaces. Software interfaces are purely conceptual other than visual. We cannot see anything, but it is visual only. Software interfaces. Next, failure rate motivators. Usually not predictable from analysis of separate statements. Okay, next, built with standard components. Well understood and extensively tested standard parts will help improve maintainability and reliability. Built, but in software industry, we have not observed this trend. Code reuse has been around for some time, but to a very limited extent. Strictly speaking, there are no standard parts for software except some standardized logic structures. Okay, like hardware, we don't have any standard parts, but some logic structures, some standardized logic structures will be there. This is a different points related to the software. Next, what is SDLC models? This is software development life cycle models. Is a spiritual model used in project management that defines the stages include in an information system development project. From an initial feasibility study to the maintenance of the completed application, there are different software development lifecycle models, right? We have so many uh, software development life cycles model which are followed during the software development phase. These models are also called software development process models. Each process model follows a series of phase unit its type to ensure success in the step of software development. Each model is benefit for the different types of projects. Here are some important phases of software development life cycles. Okay, one is waterfall model, next rad model, spiral model, v model, incremental model, agile model, iterative model, and big bang model. These are the different SDLC models. What is waterfall model? Waterfall model is a universally accepted SDLC model. In this method, the whole process of software development is divided into various phases. In the waterfall model, like a waterfall, like this, the different types of are divided various phases. The waterfall model is a continuous software development model in which development is seen as flowing steadily downwards like a waterfall through the steps of what are the different steps in waterfall model: requirement analysis, design, implementation, testing, and integration maintenance. These are the different steps in the waterfall model. Linear ordering of activities has some significant consequences. First, to identify end of a phase and the beginning of the next. Some certification techniques has to be employed at the end of each step. Okay, verification and validation usually we have to follow. Next, we will see the what are the different steps. First step is requirement analysis. We have to gather the what are the requirements to develop the actual project. Next, we have to design system design. Next, implementation of the design by using the code, which programming language we have to use. By using that, we have to implement that. Next, we have to test. Next, deployment and maintenance. Maintenance is most important. These are it is like a waterfall model is one once we have complete the requirement analysis only we can start the design. Before that, after design only we have to go for implementation. Okay, if after the system design we cannot add any requirements. Okay, initially only we have to gather all the requirements. In between we cannot add any extra new requirements to the development to the software development. It is a drawback in the waterfall model. Okay, the, we will see the some questions on waterfall model also. Okay, next one is RAD model. This is a rapid application development process. It is an adoption of the waterfall model. It targets developing software in a short period. RAD model, the target is short period to develop the software in short period. The RAD model is based on the concept that a better system can be developed in lesser time by using focus groups to gather system requirements. Okay, uh, we have to develop a better system in less time by using what focus groups. What are they? Business modeling, data modeling, process modeling. These are the 5 steps in the RAD model. First one is business modeling, data modeling, process modeling, application generation, testing, and turnover. These are the 5 phases of a RAD model. This also different teams will do different work, and this main focus is on business modeling. Okay, next data modeling, next process modeling and application generation, finally testing and turnover. Okay, this is a rapidly 60 to 90 days is the target for the RAD model. Next, next model is spiral model. The spiral model is a risk-driven process model. In spiral model, we will consider the risk also. It is very important. So many times question came, what is the importance of the spiral model risk? We will consider the risk factors also. This SDLC model helps the group to adopt elements of one or more process models like a waterfall, incremental waterfall. The spiral technique is a combination of rapid prototyping and concurrency in design and development activities. Okay, we will see how it is working. Initially, spiral model identify the objectives. What are the objectives? And perform risk analysis, review and evaluate, and develop and test. These are the 4 things we have to remember in the spiral model. What are the objectives? We have to find, the identify, and perform what are the risks involved in that, and we have to review and evaluate that, and finally, we have to develop and test. This is the diagram of spiral model. First one is determining the objectives, identify and risk. In the spiral model, every time we are developing a prototype. We will see prototype also. Prototype means it is a I will explain prototype first, then it is very clear for you. Sorry, it's gone somewhere. Yes, this is a prototype model. The prototyping model starts with the requirements gathering. The developer and the user meet and define the purpose of the software and identify the needs. This is a quick design. Okay, what happened in the prototype model? It will start with the requirement gathering. Any everything will be start with requirement gathering. This prototyping also requirement gathering. The developer and the user meet. Developer and user will be meeting here and define the purpose of the software. What is the purpose of the software? They will define. What are the needs also they will discuss, and the the team will develop a quick design is then created. This design focuses on those aspects of the software that will be visible to the user. Whichever user can see, user has to interact now. That this quick design will show that. It then leads to the development of a prototype. Prototype. The customer then checks the prototype and any modifications or changes that are needed are made to the prototype. Okay, suppose if it is a um, bank login, suppose I if we, they will create like a login system. They will show to the customer. It is like this. You have to come into this website and you have to they will make some sample like quick small design. Customer get an idea how the future system will be. Now they will tell if any changes they want like this only. By watching that prototype they can tell something, right? Okay, that prototype is just uh, like a virginal, but it is not virginal. Okay, any modifications or changes that are needed are made to that product. Now the the team, what they will do, they will do any changes are required, they will do that changes. Looping takes place in this step and better versions of the prototype are created. These are continuously shown to the user so that any new changes can be updated in the prototype. This process continue until the customer is satisfied with the system. Once a user is satisfied, the prototype is converted to the actual system with all considerations for quality and security. Suppose first time they will show a prototype. If the customer is satisfied, then they will develop the original one. If the customer told any changes, then again they will change. They will do the changes to that prototype, and they will show the uh, customer. If they are satisfied only, they will start developing the original software. Okay, that is called as these are the different steps in prototype model. First one is requirement gathering. Next, quick decision, quick design. Okay, quick decision. They will discuss. I we discuss it, right. They will discuss what are the requirements like that, and after quick decision, they will build a prototype. After that prototype, customer evaluation of prototype. They will show that prototype to the customer. If the customer is satisfied with that prototype, then they will acceptance. If it is accepted by the customer, then they will design the actual project. Then they will implement, test, and they will maintain that. Suppose if the is customer is not accepted this prototype, what they will do? Refine requirement incorporation. Whatever customer suggested, they will incorporate those changes. They will incorporate changes to the software, and they will again go to the quick decision. Then again they will build a prototype. This is the until the customer accepted, this process will be continued. Okay, in the now we'll go for the soft spiral model. Yes, this is a spiral model, right? In spiral also, they will build prototypes. Okay, first in the initial step, this is a requirement plan. Then first prototype one, they will develop prototype one, requirements and verification and validation, development and plan. If it is okay, if it is any other requirements, they will verify, then they will development and plan. Then again they will develop prototype 2. Again, if no requirements are there, they will verify and validate, test and plan. And again, this is the operational prototype. This is the final development. This is the final prototype. Okay, then now detailed design, code, integration, test and implementation. Okay, now in this prototype, yes, this is the risk. If any, identify and resolve the risk. The second phase, what they are doing, if any risk is there, they are identifying and resolving the risk. It is a iterative model. Means, okay, at a time they are not developing. Okay, in each step, they are doing some verification and validation. Okay, they are doing some resolving some risks, developing prototypes also there in the iterative this spiral model. It is a iterative development and it is focusing on the risks also. It is developing some prototypes and finally this is the operational prototype. In this after this operational prototype, then detailed design, code, integration, test, implementation, these are all normal. Every SDLC will follow this, right? Finally, the product is released here. Next, this is the spiral model. Please remember these all the whatever are involved in the spiral model. Next one is V model. In this type of SDLC model, testing and the development, the step is planned in parallel. One in one side testing is going and in another side development is also going. This is called as V model. See here, here the coding is done. Here the uh, actual yes, yes, here the coding is there. Here the first one is like here business requirement specification. Whatever the business requirement is there, here it is acceptance testing. In system requirement specification, when system integration testing is done, high level design, component testing, low level design, unit testing. Like this, from here it will start coding. First the coding is done, first after that unit testing, low level design, unit testing, high level design. In this high level design, all the components will be tested. In the system requirements specification, total system will be tested by integrating. Next, business requirement specification, total the what are the requirements is accepted. They will do acceptance testing here. Okay, first unit testing, low level design, high level design, component testing, system requirement specification, system integration testing, and business requirement specification acceptance testing will be done. Every phase, this is the verification phase and this is a validation phase. This is a developer's life cycle, this is a tester's life cycle. Developing and testing is going parallelly in V model. Next one is incremental model. The incremental model is not a separate model, it is necessarily a series of waterfall cycles. Okay, It is a series of waterfall cycles. We will see that diagram also. In each increment, uh, the requirements are divided into groups at the uh, start of the project. For each group, the SDLC model is followed to develop software. Okay, incremental model means requirements starting here are some requirement, here are some requirement divided into groups. Okay, group 1, group 2, group 3, like that. For each group, again, they have to follow SDLC model to develop the software. The SDLC process is repeated with each release, adding more functionality until all requirements are met. In this method, each cycle acts as a maintenance phase for the previous software release. Modification to the increment model allows development cycles to overlap. We'll see here. Here the first one is first some requirements. Some requirements we are analysis again. This some requirements are there. Analysis, design, code, test, increment. This is the increment one. Again, in the next step, more requirements are there, right? Again, in the this is the increment one. Analysis, design, code, test, increment two. Again, this is some more requirements will be added here, and analysis, design, code, test, increment. Okay, every time some new requirements are adding in the increment model for each increment. Okay, this is same is telling here, right? The requirements are divided into groups at the start of the project. For each group, the SDLC model is followed to develop software. Each release adding more functionality until all requirements are met. Okay, for each release, more functionality is added until all requirements are done. That is all about incremental model. Next one is agile model. What is agile model? Agile methodology is a practice which promotes continuous interaction of development and testing during SDLC process of any project. In this agile model, there is interaction with the customer. Okay, in the development and testing all over the SDLC process. In the agile method, the entire project is divided into small incremental builds. Okay, all of these builds are provided in iterations, and each iteration lasts from 1 to 3 weeks. It is also a iterative and incremental build. Okay, um, any agile software phase is characterized in a manner that address several key assumptions. These are the key assumptions of the agile model. It is difficult to think in advance which software requirements will persist and which will change. Actually, if we think about waterfall model, what is the drawback I said? We have to know everything in the starting of the project development. It is very difficult, right? Sometimes what will happen, some requirements we cannot know in the starting. We have to what we have to so after some time we came to know we have some more requirements. That's why in advance we cannot know all the requirements. Some requirements may be changed in the future. It is equally difficult to predict how user priorities will change. Yes, sometimes user priorities also changes. Okay, as the project is developing, some user may change his mind, his priorities also may change. Okay, that's why for many types of software, design and development are interleaved. Both activities should be performed in tandem so that design models are proven as they are created. Yes, next, analysis, design, development, and testing are not predictable as we might like. Yes. Next, in what are the important points of agile? An agile philosophy for software engineering stresses four key issues. One is importance of self-organizing teams that have control over the work they perform. They have to organize their team. They have to um, organizing capability. And next one is communication and collaboration between team members and the between practitioners and their customers. There should be a communication between the team members and their customers, their practitioners also. A recognition that change represents an opportunity. If there any change, they have to feel like it is an opportunity. They should not feel like hesitate to make any changes. Okay, an emphasis on rapid delivery of software that satisfies the customer. That should be what is the emphasis? Rapid delivery of software, and even that should satisfy the customer. Agile process models have been designed to address each of these issues. What one is self-organizing teams, collaboration should be there within team members and their practitioner and their customers. Uh, rec- a recognition that change represents an opportunity and emphasis on rapid delivery of software. These are the very key issues of the agile software development. Please see this once. Is it clear till now what I am whatever we are discussed? RAD model, waterfall model, incremental model, prototype model, and we discussed what spiral model also we have discussed. Is it clear? Okay. Principles to achieve agility. Highest priority. What is the highest priority in the agile? Satisfy the customer. We have to satisfy the customer. Welcome changing requirements. Any changing requirements are came, we have to welcome them. We deliver working software frequently. There is frequent working softwares has to be delivered. And next one is business people and developers must work together. Yes, business peoples and work developers has to be work together. Build projects around motivated individuals. Build project has to be built by the motivated individuals. Emphasize face-to-face conversation. Face-to-face conversation also should be encouraged here. Next one is working software is the primary measure of progress. Should not wait until the all completion. In between, we have to deliver the working software. Agile processes promote sustainable development. All the development has to be done. Okay, continuous attention to technical excellence and good design enhances. Yes, technical excellence should be there, and good design also has to be there continuously. Simplicity, the art of maximizing the amount of work not done. Okay, next one is the best designs emerge from self organizing teams. We already saw self-organizing teams. Okay, next one is the team tunes and adjusts its behavior to become more effective. The team has to be tuned to the work, and they have to be adjust to their work. These are the 12 principles. Whatever we discussed now, only this. Customer satisfaction, welcome changing. Previously, one question came. They will give some points, and which of the following is not the agility concept. They will give question like that. We will see now. Deliver working software frequently, close daily cooperation between business people and developers. Projects are built around motivated individuals. Face to face conversation is the best form of communication. Working software is the primary measure of progress. We have to give the working software and sustainable development, able to maintain constant pace, continuous attention to technical excellence and good design, simplicity, the art of maximizing the amount of work done. We have to maximize the amount of work done. Next, best architectures. Best architecture requirements designed and emerge from self-organizing teams. Regularity. The team reflects on how become more effective, adjust accordingly. These are the 12. Yeah, regularly team has to be reflect on how to become more effective, how to adjust. Okay. See, this is a one of the question based on agile software. Which of the following is not a key issue stressed by an agile philosophy of software engineering? Please answer this question. Which of the following is not a key key issue stressed? Which is not a important point in the agile process model? The importance of self-organizing teams as well as communication and collaboration between teams. It is very important, right? It is very important concept of agility. Recognition that change represents opportunity. It is also very important. Emphasis on rapid delivery of software that satisfies the customer. Yes, it is also agility concept. But this is what is this? Having a separate testing phase after a build phase. It is not that it is not required. Actually, after developing the every release, every some working software, we are doing the testing, right? Up to complete build, we need not wait up to complete build of software. Okay, that's why A, B, C is the correct answers. D is the wrong one in these answers. Okay, again, there are different types of agile process models. This is a just agility is a concept. Okay, this is a concept. We have to do like this, then it is good. But what which is implementing the agility? There are different types of models are there which are following the agility concept. Okay, agility rules. One is extreme programming, next adaptive software development, dynamic systems development method, Scrum, Crystal, feature driven development, agile modeling. These are the 1, 2, 3, 4, 5, 6, 7 models of agile process models. Okay, now we will see the different types of agile process models. First one, the most widely used agile processes originally proposed by Kent Beck. XP, this is first one is extreme programming. First agile process model. XP uses an object oriented approach as its preferred development paradigm. XP uses object oriented approach, and XP suggests a number of innovative and powerful techniques that allow an agile team to create frequent software releases, delivering features and functionality described, prioritized by customer. Okay, XP is having innovative and powerful techniques for what? To release the frequent software releases for the customer, and functionality, uh, to increase the functionality, and whatever customer is priorities of customers, to satisfy the priority of customers. Okay, there are four different phases in XP programming also: planning, design, coding, and testing. XP planning begin with the creation of a set of stories. These are called, whatever the users are telling, right? They are requirements. Those are called user stories. Each story is written by the customer and is placed on index card. These stories will be put in an index card. Suppose this is an index card. They will put these stories in index card like this. The customer assigns a value to the story. Suppose what the customer will do, this is a story number 1, this is 2, 3. These are the priorities. Okay, agile team assesses each story and assigns a cost. What the agile team will do? Agile team will do, assess the each story. Okay, each story, and they will give cost, which is costing how much it is costing, 1 lakh, 2 lakh, like that they will cost the, suppose this is 1 lakh, 2 lakh, 3 lakh, like that they will assign the cost to the all the stories. Stories are grouped together for a deliverable increment. Finally, all the stories are grouped like a, in which order they have to deliver. A commitment is made on delivery date. Before itself, they will commit a date when they have to deliver. And XP team orders the stories to be developed. Okay, again they will order whatever the stories to be developed. After the first software increment, the XP team computes project velocity, which is used to help define subsequent delivery dates for other increments. Okay, after first increment has done, they gave that increment to the customer, then again they will maintain a project velocity. Next, at what time they have to release the project. I hope you understand. They will, customers will give stories, and they will give priorities, and the developers give cost to them, and they will group like deliverable increment. Okay, they will initially they will made a commitment to when to release that, like that it will work. Follows the kiss means keep it smile. Keep it smile principle is followed by which design? XP design, extreme programming design. Okay, encourages the use of CRC. This is a previous year's question. CRC used by which programming? XP, like that they gave option. Okay, next, class responsibility collaborator. This is the CRC. CRC cards as an effective mechanism for thinking about the software in an object-oriented concept. This is a object-oriented concept context. We have to thinking the software in the object-oriented context. For difficult design problems, XP suggests the creation of spike solutions. What is spike solution? Simple program to explore potential solution. Spike solution is a, for potential solution we have to write a simple program. Okay, build the spike to only address the problem under examination and ignore all other concerns. Encouraging refactoring means iterative refinement of the internal program design occurs both before and after coding commences. Okay, this is all about XP design. It is following keep it simple, and CRC encourages CRC, class responsibility collaborator means object oriented context. Class responsibility collaborator and spike solution means very simple program to explore potential solution. Okay. Next one is refactoring, an iterative refinement of the internal program design, that is called as refactoring. We have to design the refine the internal program in a iterative way, that is called as refactoring. What are the important points here? Keep it simple, KIS and CRC, class responsibility collaborator, and spike solution for the XP design. Next, this is XP coding. XP coding encourages pair programming. Pair programming means, what is pair programming? For real-time problem solving and real-time quality assurance. Keep the developers focused on the problems at hand. What is the problem right now? They will focus on the right now problems. Needs continuous integration with other portions of the software, which provides a smoke testing environment that helps to uncover errors early. Okay, pair programming means needs continuous integration. Whenever any module is developed, immediately they has to, what they has to do, integrate all the modules. Because if there is any error, if there is mismatching is there, we can easily find initially only, right? Continuous integration, after developing so many modules, if we integrate, then it will become some problem. If there is any problem occurs, we cannot rectify that problem, right? If we do continuous integration, then very easy to rectify the error. That is the pair programming, and encourages pair programming. These are all important terminology. Okay, please remember this. Okay, friends, please remember this terminology. Continuous integration. What is smoke testing? Smoke testing means, if we after integration, if any problem came, it will come out. We will see smoke testing in detail also. Suppose example, if we buy a LPG stove, suppose if we check it, like if we lighten a lighter here, if it is something fog will come, if it is something happen, then it is uh, not working fine, like, right? That is a smoke testing. There is no problem is coming. If we test also after integration, if we test, there is no problem. That is the smoke testing. I will give full definition also. Next one is XP testing. Unit tests should be implemented using a framework to make testing automated. And regression testing means, if we give after every new thing is added, is it working fine or not? This is called as regression testing. Integration and validation testing can occur on a daily basis. Acceptance testing, customer tests. Okay, acceptance test means who has to accept, the user has to accept, right? These are all the testings involved in the XP programming. Next one is adaptive software development. These are all, what are these? Agile software developments, right? First one is XP programming. The next one is adaptive software development. The adaptive software ASD stresses human collaboration and team self-organization. This also, all are following the agile principles only, right? Human collaboration should be there and team self-organization is also should be there. Adaptive software development uses an iterative process. It is also using iterative process that incorporates adaptive cycle planning, relatively rigorous requirements gathering methods, and an iterative development cycle that incorporates customer focus groups, real-time feedback mechanism. These are the different steps in the adaptive software development. Speculation. Okay, basic requirements. That is time box released plan. Okay, within that time box, we have to release. That is a time box released plan. This is also very important term. It is came in the one of the matching type question. Time box released plan is belongs to which type of development? That is adaptive software development. Next one is collaboration. Okay, requirements gathering, mini speaks. Next, I will give the definitions also. Learning, components implemented, tested. Next, software increment adjustments for subsequent cycles. We will see what is speculation, collaboration here. Speculation means project initiation. Next, adaptive cycle planning. What is customer mission statement, project constraints, basic requirements, time box released plan. All these are comes under speculation. Next, collaboration. Motivated collaboration means interaction, right? Motivated people work together in a way that multiplies their talent and creative output beyond their absolute member. If they are working together, what will happen? They will put their talent and they will give creative output, right? That is called as collaboration. Learning also will very important. Learning will help team to improve level of understanding regarding problem. Okay, if we don't want to learn, we don't get anything, right? We don't understand. If they don't understand anything, they have to learn in three ways: focus groups, FTRs, and postmortems. These are the learning ways in the adaptive development, adaptive software development. What is focus group? What is formal technical review? These also important terms. Focus groups means the customer or end users provide feedback on software increments that are being delivered. This process is direct indication of whether or not product is satisfying business needs. Focus groups means the customers. They will give feedback on the received softwares, whichever they got the softwares. What it will tell? They are satisfying the business needs or not. Next one is these are the learning. How they can learn, how the team is learning, how the developers are learning. Focus groups. By the feedback of focus groups, they will learn. Next, formal technical review. ASD team members review the software components that are developed, improving quality and learning as they proceed. They has to review the components whatever they are developed, and they has to improve the quality and learning as they proceed. Okay. Next, yeah, as and then they are learning, they will improve the quality of that products, right? Postmortems. The ASD team becomes introspective, addressing its own performance and processes. Okay, wait a minute. These are postmortems means teams becomes introspective, addressing its own performance and processes. They will they only get what are their performance and how they are doing. Next one is dynamic systems development method. Dynamic systems development method defines three different iterative cycles. This is also one of the agile methodology, agile development model. Dynamic systems development method. These three different iterative cycle. Functional model iteration, what is the produces a set of incremental prototypes that demonstrate functionality for the customer. What they will produce? Set of incremental prototypes, okay, that demonstrate initial first step is functional model iteration. In the functional model iteration, they will produce a set of incremental prototypes we already saw, right? Prototypes means they are just a uh, preview, just that is a just model, that is not a complete software, right? That will what that prototype will do, that will demonstrate functionality for the customer came to know the functionality of the original software by watching the prototypes. This is functional model iteration. Next, design and build iteration. Revisits the prototype built in functional model to ensure business values implementation. They will again revisit that prototype built in functional model to ensure business values implementation. Okay. Next, implementation places latest software increments. These are the three processes in dynamic system development method. We have to do more revision for to remember all these things. Please do your revision also. Next, dynamic system development method. These three cycles are preceded by two additional life cycle activities. Next, feasibility study and business study. Basic business requirements and constraints. What are the basic business requirement we will see in feasibility study. In business study, establish the functional and informational requirements, defines the basic architecture and identifies the maintainability requirement for the application. Okay, in this what we will see, functional and informational requirements. What are the functional requirements? What are the informational requirements? What is the basic architecture and the maintainability requirement? What has to be maintained after the development? All this comes under the business study. Okay, functional requirement, informational requirement, basic architecture, what is the maintainability after the development is to be considered. Next one is Scrum. Uh, this is the last one. Next one is Scrum. Scrum is an iterative and incremental agile software development method. This is also an iterative and incremental agile software development method. Okay. Scrum incorporates a set of process patterns that emphasize. Next, what is Scrum is incorporating project priorities, compartmentalized work units, communication, frequent customer feedback. Okay. Compartmentalized means small work units. What is a Scrum? Scrum emphasizes the use of set of software process patterns that have proven effective for projects with tight timelines, changing requirements, and business criticality. Scrum, what is Scrum is telling? Use of set of software process patterns that has already proven effective for projects. For which type of projects? With tight timelines, within short time, and we have to change our requirements also, and business criticality, business we have to satisfy the business requirements also. Those software process patterns it will follow. Scrum, what will the Scrum emphasizing? The use of a set of software process patterns that have proven effective for projects, tight, tight timelines, changing requirements, and business criticality. Next one is framework. What is the framework activity for Scrum? Requirement analysis, design, evaluation, delivery. Within each framework activity, work tasks occur within a pattern called a sprint. Okay, we'll see that also what is a sprint. Each process pattern defines a set of development tasks and allows the Scrum team to construct a process that is adapted to the needs of the project. See here, this is the actually this is a sprint backlog. Wait a minute, I will bring my notes. See here, it is. Wait a minute, please. Yes, the first one is the product backlog. What is a product backlog here? Prioritized product features desired by the customers. Whatever the customer requirements are there in the product backlog, what they are requiring for their product. Prioritized product features desired by the customers. Okay. Next one is initially what is it here? Here it is their input from the customer. Here initially input from the customer and end users. Customers, team and other stakeholders. Okay, customers and stakeholders also. What is stakeholders? Everyone. Maybe customers, end users, and here everyone will come under stakeholders. Users, everyone is come under. They will first. You will take input from these people. These are, here product owner will be there. Product owner will be there here, and this is a product backlog. Now there is a sprint planning meeting. Sprint means every sprint they will do some task, right? Task 1, task 2, like that. This is a sprint backlog. Yes, this is a backlog items expanded by team. This is sprint backlog. Yes, sprint planning meeting will be there here, friends. Before the sprint, before this sprint, what is sprint planning meeting will decide me is how much to commit to do by sprint end. There is a sprint, right? This is a sprint. This is a sprint. For every cycle is a sprint. They will decide in the sprint planning meeting what they will decide, what we have to do, how much we have to commit to do by the sprint end. That is decided in the sprint meeting. What is sprint backlog? Total requirement from client take again. Okay, total required from client to take again. That is sprint backlog. This is sprint backlog. Okay, the futures assigned to that sprint. Okay, next product. Next one is They will decide in the sprint backlog whatever they have to do in that sprint. Okay, what in suppose if this sprint is 30 days, they will do, there is a 15 minutes daily meeting is there. Okay, they will learn members what did you do since last scrum meeting. There is a scrum meeting also there. They will discuss whatever they did up to now. Do you have any obstacles, any problems is there, just they will do stand up meeting. What will you do before next meeting, before next meeting, what you will do, what is your task. That is the overall scrum process. First one is the, this is the input from the customers and users and stakeholders. Next to here product owner is there. There is a product backlog. These are the whatever is requirement from the customer. Here there is a sprint planning meeting. They will decide how much they has to finish in uh, each at the sprint end and sprint backlog. They are tasks in the sprint backlog. Okay, how many tasks are there, like that they will maintain in the sprint backlog. Okay, next there is a sprint is 1 to 4 weeks. Okay, that means 30 days means 1 to 4 weeks is there every sprint. After that, while developing the sprint, there is a stand up meeting. If there are any problems, they will be discussed in the middle. There is a scrum master also there. Scrum master means he will do he will manage everything. And product backlog refinement, suppose if anything they has to add, they will here they will do product backlog refinement. That means if there any change is needed, they will do here product backlog refinement. Finally, if everything is finished, finally they will new functionality is demonstrated at the end of sprint. If everything is done, they will release a new product. This is all about the sprint backlog and back. Next one is here product backlog, requirements of the customer, sprint backlog, and here there is a stand up meeting, and here is a product refinement. Finally, they will release the functional software. Next one is future driven development. This is a future driven development. This is based on the futures. What are the features? Based on futures, they will development the software. Here see, feature driven development, develop an overall model. Next, build a feature by feature. Suppose login feature and uh, suppose uh, username, everything. All are feature like, right? Password, like that. They will list the few features in that model. Plan by feature, they will plan which feature we have to develop. They will design by feature, and they will build the by feature. This is called as feature driven development. Okay, please read this if you want more details. It's a client valued function because features are small blocks of deliverable functionality. We can easily users can describe them more easily, right? What features you want, if we ask what feature you want, they will easily uh, tell us features by features. Yes. So one more point is crystal. What is crystal family is actually a set of example agile processes that have been proven effective for different types of projects. These are crystal means these are already proven agile processes. Proven agile processes. Okay, effective, proven effective, that have been proven effective for different types of projects. The intent is to allow agile teams to select the member of the crystal family that is most appropriate for their project environment. Already some agile processes are there that has been proven effective for different types of projects. Now the team has to select the most appropriate crystal for their project environment. That is called as a crystal. Okay, crystal means it is already proved for the different types of projects. We have to now the team has to select the suitable crystal for their project. Here see, there is a this is a December 2019 question. Scrum, left side Scrum is there. These are all, what are these? These are agile development models, right? Whatever we have discussed till now, all are there here, right? Agile software development models. Scrum, adaptive software development, extreme programming, feature driven development. What is Scrum is matched with which option? Yeah, sprint backlog, right? Sprint backlog means for each sprint what they have to develop. It is there in Scrum method only, sprint backlog, right? Adaptive software development is time box released plan. Extreme programming is CRC code. We already saw, right? Classes, responsibility, and C means what C means? We'll see here. Yeah, here only, right? Class, responsibility, collaborator. It is an object oriented context. CRC cards. XP, extreme programming, is using CRC card, and feature driven development. Action, this is based on features. That is, it is here it is given action, but it is a feature driven development, right? That is the A is matching with 2 and B is matching with 4, C is matching with 1 and D is matching with 3. Option 1 is the right answer here. Yes, option A is the right answer. All of these are the agile process models. Please do your revision for this agile. This is the diagram of agile, friends. Development 1, development 2, development N, release. If it is no, then again it will be process. Iterative model also we missed this. It is a particular implementation of a software life cycle that focuses on initial simplified implementation, which then progressively gains more complexity and broader feature set. It will adding more features in each step. Okay, that means we are breaking down the software development of a large application into small pieces. We are developing the software in small pieces. Okay, suppose this is a iteration 1. Again, in iteration 1 we already all requirements are there with us. Now what we are doing, we are doing the project in small iterations. Here some iteration we are doing, again we are here some functionalities we did, and in the next step we are did the some functionalities. We are not gathering the requirements again. Please observe here, only once we are gathered the requirements. In the next step we are not gathering any requirements, just we are doing the development by iteration. Okay, that is called as the iterative model. Big bang model is a focusing on all types of resources in software development and coding. No very little planning. This big bang model, without any planning they will do. Okay, The requirements are understood and implemented when they come. Whenever the requirements are coming, they will understood and they will do. This type of model is not suitable for big project. This is suitable for only small projects with smaller size development team. Okay, it is useful for academic software development projects. Okay, next one, this is a big man, time, effort, resources only will develop and will release the software. Prototype model, we already discussed this prototype model. We'll see the here one question is, it is a previous year's question. Waterfall model, please tell me the answer. If you know the answer, please type the answer. Don't please don't be silent, please respond. Someone is there, please respond in the chat box, it is very good. Waterfall model, incremental, prototyping, rad, which one is matching with the waterfall model? E-business software that starts with only the basic functionalities and then moves on to more advanced features, and an inventory control system for supermarket to develop within 3 months, a virtual reality system for simulating vehicle navigation in highway, automate the manual system for student record maintenance in a school. Incremental, initially we will see what incremental model, which is matching with incremental model. Incremental model is matching with this, right? E-business software that starts with only basic functionalities and moves on to more advanced features. Incremental means that is only, right? In every increment, we are adding some more functionalities. That is a incremental, right? That's why B is matching with 1. What is prototyping? Prototypes. Prototypes means that is virtual for simulating vehicle navigation in a highway. Virtual reality. It is not a original, just it is a virtual reality. Just for simulating vehicle navigation, how to navigate the vehicles. We are developing a virtual reality. That means it is a prototype. Next, RAD, an inventory control system for supermarket to be developed within 3 months. That is a rapid application development. Okay, to develop the software very fast. That means B is matching with 1, A is matching with 4. This 4 is the right answer here. Next question is, which of the following is not one of the principles of agile software method? Embrace change or incremental delivery is there, right? We remember there is a incremental and iterative development in the agile. Customer involvement must be there. They has to embrace the change. Whenever there is a change come, they has to welcome the change. They feel like an opportunity. These are very important. Following the plan, there is no plan in agile, right? They are immediately they will plan, they will change the requirements, everything. Nothing plan is there in the agile method. That's why 4 is the right answer here. This is the previously we already discussed this question. This is software engineering is an engineering discipline. uh, engineer is an engineering discipline that is concerned with. What is the answer? Answer is 4. It concerned with all aspects of computer based system development including hardware, software and process engineering, right? Next, no, sorry, software engineering and this that is concerned with. Yes, uh, development hardware. No, no, this is not the answer, friends. Sorry, nothing is related with hardware, right? This is only all aspects of software production. Software engineering is what is we are doing in the software engineering. That this is all about software production. Right answer is 3. Yeah, next question is the prototyping model of software development is what? A reasonable approach when requirements are well defined, a useful approach when a customer cannot define requirements clearly, the best approach to use for projects with large development teams, no, a risky model, rarely, no. In prototype model, initially we don't know the complete requirements. Okay, that is the main important point in the prototyping model. The requirements are not well defined. A useful approach when a customer cannot define requirements clearly. This is the prototype model. Next, the major shortcoming of waterfall model. What is the disadvantage of short waterfall model? The difficulty in accommodating changes after requirement analysis. Yes, once the requirement analysis is over, we cannot accommodate any changes. Okay, that is a shortcoming. The quick design of a software that is visible to end users. What is a quick design that is visible to the end users, friends? That is prototype, right? Just we are designing the quick model. The dash model is preferred for software development when the requirements are not clear. What is this? This is evolutionary model. This is not waterfall, not rational, unified. Rapid application development is also not. For all these, we have to know the requirements in the starting. Evolutionary model is the right answer. Okay, friends, this is all about the SDLC models. I completed everything from the software development life cycles, agile methodologies, and the previous year's questions based on the SDLC models also. Okay, if you have any doubt, you can watch the recording. Okay, thank you, friends. Thank you for watching. Please inform your friends. Please share with your friends. Okay, that is my request. Next, in the next session, we will go for software testing. Okay, thank you, friends. Bye. Thank you.